Hello, this presentation is for ELE 8932, which is the PLC course. The first thing that you'll want to do is to configure a program called RSLINX. To find that program, click on the search icon and type in RSLINX with an X, and you'll find a program called RSLINX Classic. Click on that. Within RSLINX Classic, click on the Communications tab and then click on Configure Drivers. And down here, use the scroll to find Ethernet IP and then click Add New. OK. And here you'll see a list of two IP addresses. One that starts with a 10, that's the college network, and one that starts with 192, that's the PLC network. So click on that line, click Apply, OK. And then once you've done that, you should click on Close, and then come over here and expand on Ethernet IP. Eventually you should see the IP address of the PLC, which is .30. And then click on this tab, and again expand until you see the controller. The controller should have the number 00 beside it. That's the slot number. And it's 1769 L24ER QBFC1B. Okay, and then click on that. And all you have to do is verify that you see all of the I/O modules. And we'll be using module 1, which is the digital or discrete I/O. Okay, and you can minimize that. And once the next step is to open up the Studio5000 software, and we'll do a search and type in Studio, and I found it. Click on that, and we're going to do a new project, so click on New Project. And you want to make sure that there is a list here of all the different controller families, and the one that we're using is called the Compact Logix 5370. So open that up and move down until you find this controller name. Okay, make sure you've got the right one, and then I'm just going to type in a name. You must have a name here of Lab 1, and then click Next. Just verify that it's revision 29. I'm going to put a comment here of Lab 1, and then click Finish. And I'm just going to overwrite that because I created one previously. Now this is the screen that contains the controller organizer and an area where we'll be writing our program. But to see the current program, let's go to Main Program, Expand, click on Main Routine. So right now there's actually no program. But before we move further, you want to make sure that the path is set up to point to the PLC that we want to use. So click on Allen Bradley Ethernet IP, click on this, click one more time to expand, and then highlight the line that has module 00 in it, and then click Set Project Path. And then you can close this window. So make sure that this path indicates the Allen Bradley project path. The next thing we can do here is click on an icon that stands for Examine If Closed or Examine If On, and we're going to place it onto the rung, and the same thing for Output Energize. Now we still have errors because we haven't associated a name with these two instructions. So I'm going to add a name here, switch 1, and I'm going to add a name here, lamp 1. Okay, and we still see that there are errors here, even though we've given the Examine If Closed and the Output Energized names. We have to right click on the name, say New Switch 1, and tell it that we want it to be a Boolean data type, so that it only has two possibilities, true or false, and it's a base tag. I'll explain the difference between base and alias a little bit later. So same thing here. It's a Boolean base tag create. And now we don't have any errors. Now to download this into the PLC, you have to go up to this box and click on download. But just before I do that, a better way to verify that you don't have any errors, a quicker way actually, is to verify routine. And down here it gives me the messages that I don't have any errors, so I can move ahead. So now click on download. And what download does is transfers the program code to the PLC. So click download here. Those warning messages are just if there were real hardware there that might run when you download the program, so it's a safety feature. And then click yes when this message comes up. And you should have all three green lights turned on here. The run, controller OK, and the IO OK. And you'll see that we have a program here. Now these are called base tags. They don't actually point to any real hardware. So I could manipulate the inputs right on this screen by right-clicking and going to toggle bit, and it turns the lamp on. I can toggle it again and it turns it off. Okay, I'm going to stop this from running for now, so go offline. I'm going to add another rung. Okay, I'm going to add it right here. Maybe this is a quicker way to do it. And I'm going to have an AND instruction and an OR instruction. So I'm going to add another examine if on instruction right here. And I'm going to add one down here. But what I'm going to do is put a branch. And what that branch does, it's like an OR operation. So I can put one more instruction in here. I'm going to give names to all these switches. So this is going to be switch 2. Switch 3, and I'm also going to have a second output. I'm going to call it lamp 2. Okay, and why do we have errors on these lines? And that's because we haven't specified or defined the tags for switch 2. And I'm going to do create for switch 3 and switch 4. Oops, I don't think I said OK to that. And we also have lamps 2 over here. Okay, so I'm going to download that code. And sometimes if you make a mistake, it won't automatically go into run mode. So you want to make sure that you are in run mode. That's very important. One of the ways that you can tell that you're in run mode is that these bars go green. Okay, so if I wanted to test this little bit of code, I would right click, toggle the bit. But why does this bit not come on, or why does this lamp not come on? Because this is an AND operation, so all of the inputs must be true. So I'm going to toggle that bit, make it true. Now the lamp comes on. But for this one, both of these, or sorry, any of these have to be true for lamp 2 to come on. So I can turn on lamp 3, sorry, switch 3, and that turns on lamp 2. And if I turn this off and turn this one on, that comes on. Now let me show you what happens when you have an error. So if I go offline, I'm going to put another instruction here. And if I do a verification, it tells me that I have a problem with instruction on rung 1. And if I do try to download this now, let's see what happens. See, it won't actually allow it to download because it has an error right here. So to fix that error, I'm going to delete this. Delete the instruction. I don't have any more errors, so I should be able to download. Now, this is the case I was mentioning, that if you had an error, you fix the error, the next time you try to download, it won't automatically go into run mode. So you have to click on this bar and click on run mode. And now it does. And if you were to, I think if you were to download again, so I'm going to go offline. So since we fixed that error one time, I think it will automatically go into download mode and run mode. Let's just give it a try. Yes, it did. So while we're here, I want to show you a few other things. These are the controller tags. So these are the tags that actually represent hardware input and output. And I can expand on this window here so we can look at the inputs. And the inputs are the data. And there's two ways to look at the input data. You can see that it's kind of a string of bits of information. And right now, the only bits that are turned on are bit 1 and 3. And that's because those are two switches that are normally closed. So if they're closed, they're equal to a 1. And the local tags are the ones that I've created, and I can click on parameters and local tags, and those are the things like the lamps and the switch, and it tells you their current value, and it tells you that they're decimal information here, and it's a Boolean data type. If I want to delete the tags, I must be in edit mode. If I want to change the names or configuration, monitor mode allows us to see the current value of those tags. So if I go to main routine and I change switch 1, I toggle it so that it's now closed, and I go into my tags, you'll see that switch 1 is closed. So it's continuously updating that information. Back to main routine. I want to show you another instruction that's very important, is that if I, in my third line, add something called an examine if open or examine if off, and I'm going to call it switch 6. Just going to go in sequence, and it's still got an error because I have to define it and do create. Now what this instruction does is if the switch is open, this instruction is true. So what I can do is leave that false or open, and then close these two. But we'll run the program to see what happens. So we'll download it. Okay, always check for errors down here. Okay, verify that you're in run mode. The I/O is okay. So now for this lamp to be true, this switch has to be closed. So I'm going to toggle it. This switch has to be closed. So I'm going to toggle it. And this switch is open. Okay, and if I go to my tags and look at switch 6, okay, you can see that it's a 0, and switch 1 and 2 are equal to a 1. So this is 0, but it's an examine if open, so it's true. This is an examine if closed, it's true, and this is true. When all three of these inputs are true, it causes the output to go true or turn on. Okay, now that we've done this, I'm going to go offline, and I'm going to load another program. I'm going to go to File, Open, and I have a program called, I would have created it very, very recently. And I think it's called Simulator Variables. So I'm going to open that up. No, I don't want to. Okay, and I think this just may be a blank program. Yes, it's just a blank program. But what's special about this program is if I open up the local tags, there are already many tags listed here. Sim out 0, sim push button 0, sim switch 4, and so on. These have been set up so that they match up with the variables used in our HMI. Okay, so I'll make sure that this program is on Brightspace so that you'll have access to it. But now that it's there, I'm going to open up the HMI Simulator. So click on the Windows and go to FactoryTalk View Studio. And the first thing I need to do is go to Tools, Application Manager, and Restore Application. Next, then I have to search for the application. And I will be giving you this application on Brightspace. But right now I have it stored in a directory and it's called PLCIO. So open that up, click on Next, Finish. This takes a few seconds. Okay, it's done, so cancel this window. And then I want to go to File, Open Application, and click on PLCIO Fall 2020. Open that. All right, after everything seems stable here, what we want to do next is go to Displays and open up the one that says Lab I/O Panel. So double click on this. Okay, and what this is trying to simulate is what appears in the actual lab in CA219B. Since we're not able to be there, we can simulate the I/O. So let's try running this. So if I click on, and I want to make sure this program is running, and it's not, so I want to do that first. So I'm going to go to the program, and I'm going to delete that first rung. And when you do that, I consider this a blank program, but we can download that blank program. And you want to make sure it does say run once we're done. And there's actually no code, but the variables are still in memory that we can access. And I'll show you how to do that in just a second. All right, so under Ladder Simulator, you can see it's a blank program. We are in run mode. I can look at all the tags. These are the tags. Now the reason I'm using specific names is because if I do go to the simulator and I just open up some of the things that I've configured on the simulator, I can go into animation, color, and you can see for that particular button, it's going to have a color of gray when it's false and a color of red when it's true. So it's main program sim out 3. So that's the name that I've chosen. So that's why it has to work with that particular name. And I have a name for each of these buttons, the sliders, the bar graph, that match up with what we have in the program. So when I click on the run or test display, okay, all of these things appear to be operating. And what I'm going to try to do here is just to close this window or make it a bit smaller, because I want to have the tags and this window up on the screen at the same time. So I'm in run mode. I'm running the simulator, and I should be able to go into here and make sim out 0 equal to a 1. I don't know if I can have these two things on at the same time. Let's see, I'll close this window. I'll close this window. I think the reason I can't have it at the same time is they'll, if they're overlapping, they'll close. But if they don't overlap, I don't think they will. Well, let's just see. Okay, and I'm going to change this to a 1 again. I may not have hit enter before. Okay, and that caused that output to change. I simulate this by putting a 1 there. That causes that output to change. So I can test each one. Okay, so I'm writing to the output, and if I want to verify the input, I can do that right here. So if I press this push button, you can see the push button 0. Yeah, they're changing. Push button 1 is down here. Push button 4. Switch 5. Switch 6. Switch 7. Push button 0. Push button 1. Push button 2. Push button 3. Now, the two red push buttons are normally closed. That's why you'll see that they're on right now, unless I press this. And hold it for at least half a second for the push buttons. So all those seem to work. And if I move my VIN slider, you can see its value is changing, and it goes from 0 to 10,000. And if I write a value in the output bar, 2350.5, let's say, and then we have that in the scroll bar, and the scroll bar goes up to 10,000. And in the variable, I can type in a value of 22.6. It appears in variable A, and I type in a value of 44.2, and it appears in variable B. So everything seems to work okay. Now, if I wanted to write a program, okay, let's say I wanted to write a program to test out the simulator, I'll go offline. And now I want to get out of the program tags. So I need to go to View and see the controller organizer, which is right here. Go to my ladder logic program, and I'm going to do just a push button and a switch, okay, or a switch and an output. So I have to add a new rung. I'm going to put an examine if closed instruction and an output energize, and I'm going to use the name, the appropriate name for switch 4. So there's a pull down window that I can actually pull down and look up switch 4. This actually makes it quicker when you do that. Use this pull down window, and we want to go to simulator output 4. Okay, and we can check that there's no errors. Down here we see that there are no errors. We can download our program. Okay, and now that we have the simulator connected to this software, I should be able to close this switch by clicking on it. And it closes the switch in software, or makes the instruction go true, makes the output go true, and turns that on. So everything we expected to work does. We'll just do one more try here. We'll do a start and a stop. So we'll make push button 0 the start button, and push button 1 the stop button, and out 4 will be like the run. Okay, so I'm going to add another switch, and I'm going to add another branch, put this switch into here, and add another switch. And here I'm going to put sim out 4. You can have an output as an input instruction. So this is the address of the output. And here I'm going to put the stop button. So that's going to be push button 1. So we'll find push button 1 right there. Okay, there doesn't seem to be any error, so I'm going to download this. Okay, so now we want to test this out. Well, the push button 1 is a normally closed switch, so that's why this instruction is true, because the switch is closed. Switch 4 is open, and output 4 is off. But when I press the push button, I used switch 4, but we'll change that around. When I close this and then open it again, it keeps the output on. So actually what I'm going to do is make a change here, because that wasn't a good choice. I'm going to use push button 0 for this. So I'm going to switch it to push button 0, which is right here, and then download that again. And I'm doing all of this remotely at home on the actual PLC that's in the lab. Back into run mode. And now if I press this push button, that light comes on. If I press this one, it goes off. So this is basically like a start-stop for a motor control.